All right. This video I want to talk about another example of calculating the skewness of a data. So for this case, we're calculating the skewness of a claim size. So you're given the annual claim size of an insured has the following probability distribution. The claim size is 100, 200, 250. Probability is 30%, 20%, 50%. By just plot all these numbers, you have 100, 200, 250. Let's see, 100, 200, 250. Then it's 30%, 20%, and 50%. You can actually tell that the majority of the distribution actually is allocated towards to the right. Therefore, the skewness, it's a skew to the left. It's called a skew to the left, and you are expecting to have a skewness less than 0. That's what a skewness is measured. It's about the symmetricness of this distribution. But you want to quantify it. Sometimes when the data is very complicated and different structure, when you are not able to easily visualize it, then this way you will be able to quantify it, whether it's very skewed or it's quite a symmetric. If it's a perfectly symmetric, your skewness should be equal to 0. Now let's calculate the math. We know what answer we're looking for, or we should expect. In order to calculate skewness, it's mu to the, is called a central moment, mu 3 over standard deviation to the power of 3. This mu 3 is not average to the power of 3. This mu 3 is a central moment of the distribution. So skewness equal to mu 3 over standard deviation to the power of 3, where mu 3 is the expected value of x minus mu to the power of 3 divided by standard deviation to the power of 3. We actually did the math from a previous question, and I think we derived it is equal to, I'm going to start using the formula from here. Let me use a number. This is a formula that after we simplify it, then we can use it here. And it is equal to expected value of x to the third minus 3. I'm going to use a different notation, just expected value of x, make it easier. Expected value of x squared, and plus 2 expected value of x to the power of 3 divided by standard deviation to the power of 3. All right. So this is one way to deal with it. You can calculate the raw moment for each of them. Then there's another way to deal with this, which is you can just directly calculate the third central moment from here, from this formula. All right. Now I'm actually going to switch the method. That's why I want to give you two different questions, because you can approach this relatively differently, but they're actually same. You will get the same results. Another way is you just calculate this part directly. And you actually can calculate the variance directly as well, because there is, or standard deviation, because there is a well-defined formula for it. So let's try that. We still need to calculate expected value of x. Expected value of x is really just mu, or it's really the average. So it's 100 times 0.3 plus 200 times 0.2 plus 250 times 0.5. And you should end up with getting an average is 195. Now let's calculate the variance. Why we need a variance is because variance is standard deviation squared. So this is equal to the variance. And variance has its own definition, is the expected value of x minus mu squared. This is actually called second central moment, mu squared. And sorry, not mu squared, it's a mu 2. However, we also know a formula that e to the x squared divide minus expected value of x whole thing squared. We have the multiple way to process this. But now I'm going to apply for, I'm going to use the appropriate color. I want to apply this formula directly, which is I'm going to use this formula directly. Instead of calculating each wrong moment separately, put them together, I calculate this directly, which is going to be expected value x minus mu. What is x? It's 100. What is mu? You just calculated 195. And you need to square it, multiply the corresponding probability, which is 0.3. Second case, 200 minus 195, square, multiply 0.2. And plus 250 minus 195, which is mu squared, multiply 0.5. And you should end up with getting, let me see what you get. You should getting 4,225, and that will help you to get a standard deviation equal to the square root of that. Now you need to calculate the third wrong moment, which is also called mu3, or expect the value of x minus mu to the power of 3 is equal to 100 minus 195 square 0.3. Oh, sorry, to the third. Let's highlight this. It's the square, it's a square, it's a third, it's a third, and plus 200 minus 195 to the third, multiply 0.2, 250 minus 195 to the power of 3, multiply 0.5, you end up with negative 174,000. Okay, it's a third wrong moment. It's a third central moment, second central moment. And now you can almost put all these together because I'll give you a little bit of highlights. Call this, we need this, which is the square root. Sigma is going to be square root of 4225. And we also need the central moment. And we're going to use, it's actually not exactly the same thing, but I'll use this one. This one is the third central moment. And he can help you to calculate skewness. So the skewness is equal to negative 174,000 over square root of 4225. Remember this to the power of 3. So this is your standard deviation, and this is your third central moment, and you'll end up with negative 0.6336, and we are expecting a negative skewness.